This is the lecture for week 6. Last week, I gave a lecture on limits and continuity. And we have finished up to example 3.7 and example 3.8. So example 3.7 and 3.8. Now I go to 3.2. If you refer to your notes, 3.2 is on the limits as x approach C and fx approach L and infinity. Okay, we can take any value for C, any value for C. You can take any value for C. So we're going to solve what is the result for limit as x approach to C for any value, and then we expect that the answer will be L, and the answer will be, sometimes the answer will be infinity, or maybe your answer can be also be 0. Okay, in terms of you can write like this. Let's say I have limit here, limit x approaches C, fx, this is in a general term, this is equal to L. Or we can also write like this, limit of x approach to C, fx, this can be we can also have the answer of infinity. Okay, look at the first example, example 3.9. Example 3.9. Suppose the function here, we have fx, we have if x is less or equal than 2, this is what I call the negative side. Fx less than 2, then the function here is x raised 2. Then if x is greater than 2, the function is x plus by 2. So I want to find the limit of x approaches to 2 for this function. I want to find this. Okay. So since we have two directions here, and this direction is on the x approach to 2 negative side, and this is where you have x approach to 2 in the positive side. Okay. So we have to, if you want to find this part, you want to find x approach to 2. Okay. You want to find x approach to 2. We need to find limit of x approach to 2 in the positive side of x. Then I have to find x approach to 2 in the negative direction. So by definition, if limit of x approach to 2 in positive direction of fx equal to limit of x approach to 2 in the negative direction, fx, then therefore limit x approach to 2 fx is equal to L. Let's say if this one equal to L and this one also equal to L, then limit x approach to 2 is equal to L. Okay. Now, by looking at this example, so I want to find, first I want to find limit x approach to 2 in negative direction, fx. So our function here is fx is x raised 2, or I put here x raised 2. So this is equal to, so because of the negative direction, this equation, let's say, so we just substitute s is equal to 2 into this function. So we'll get 2 raised 2 is equal to 4. Okay. Then the limit of x approach to 2 in positive direction. This is a positive direction because of x greater than 2 is positive direction. So x greater than 2 means if I have a graph here, here 0, 1, and 2, x greater than 2 is this part, this function. Now for x is less than 2, is referred to this function. So this is as x approach to 2 in negative direction, then limit of x is approach to 2 in positive direction is, the function here is x plus by 2. So if you substitute 2 into this function, you will get 2 plus 2 is equal to 4. In other words, we have shown that limit of x approach to 2 in negative direction equal to limit of, so we'll put it this, fx equal to limit of x approach to 2 in positive direction. This is equal to 4. And therefore limit x approach to 2 fx is equal to 4. This is the final answer for this example 3.9. Now look at example 3.10. So we have example 3.10. Now we go to example 3.10. Example 3.10. Okay, I want to find a limits of x raised 2 plus 3 x approach to c, or x approach to 2. Now, for this case, we have only one direction. Okay? We do not know whether negative or positive. So, example 3.9, we have the negative direction and positive direction. But for this case, we are given only one direction. So to solve this one, you just plug in the value of 2 here. So we just plug in the value of 2 here. You get 2 raised 2 plus 3 is equal to 4 plus 3 equal to 7. This is how we solve the limit here. Okay, B. I want to find the limit of x approach to 2 over x minus 2. this also we have only one function. Okay? Then to solve this one, you can just substitute value of 2 here. So this is equal to 2 over 2 minus 2, or 2 over 0. This is equal to any value divided by 0 is equal to infinity. Then C. Now, C is a quite complicated. C is quite tricky. So we have the function in terms of what you call rational function. So I want to find limit x approach to 2. I have a rational here, x minus 2 divided by x raised to minus by 4. Now, if you want to solve this one, this can be this function can be simplified as, because of x raised to minus 4, you can think one value. Okay? So this can be written as limit x raised to x minus 2 over x minus 2 multiplied by x plus 2. So the denominator here, if you multiply again, the denominator here, x multiplied by x is x squared, x multiplied by 2x is 2x, negative 2x multiplied by x is negative 2x, negative 2 multiplied by 2 is negative 4. So if you multiply again, you get x squared minus by 4. So this is quite tricky. It's a rational function. So if you find this type of function, you have to solve like this. Okay. Now this can be cancelled off. We can cancel off this one and this one. So the thing here becomes limit of x approach to 2, 1 over x plus by 2. Then if I substitute 2 into this function, I will get 1 over 2 plus by 2 is equal to 1 over 4. Let's say I have one more example. Let's say example C1. Let's say I have limit of x approach to 2. I want to find x minus by 3, x squared minus by 9, for example. So this one you can solve. The simple way to solve this one, we can put this here as a limit of x approach to 2, x minus by 3. This thing become x squared minus by 9 is x minus by 3 plus by x plus by multiply by x plus by 3. So this can be cancelled off here. So we get limit of x approach to 2, 1 over x plus by 3 is equal to 1 over 5. This is how we solve the what we call rational functions in terms of this is a special case of rational function. Now D, I want to find D, and this is also quite tricky. Limit of x approach to 2, x raised to over 16 over square root of x minus by 2. So if you find a radical function, this is a radical function. Square root of x is radical function. So to solve a radical function here, we can solve by to get away this radical function, this radical. You can put this way. You can solve. You can multiply. So if I have radical like this, square root of x minus by 2, to solve this radical, I just multiply by 2x minus 2, I multiply by square root of x plus 2. Then if I have, this is one example, if I have square root of x minus by 3, I want to solve this radical, I just multiply by square root of x plus by 3. This is how we solve the radical here. So now, to solve this one, you just multiply the bottom here, the denominator. This is a denominator. This is a denominator. Denominator. And the top here is a numerator. This is a numerator. Now to solve this radical here, so what I said just now is just multiply by square root of x plus by 2. So the bottom here, square root of x minus by 2, I multiply by square root of x plus by 2. The top here I have here x squared minus by 16. Now if I multiply the denominator here by a new number here, a new function here, the above also I have to apply by the new function. The new function x plus by 2. You cannot just multiply the bottom here without multiply the above with the same value. So if you want to multiply the bottom with a certain value, the above also, the numerator also you have to multiply by the same value of the denominator. So if you can solve this one, this will be you can get the same thing. Okay, now I do not want to cancel this one, because I want to get it from this square root of x minus by 2, I just multiply by square root of x plus by 2, the bottom one. Then the top one I also have to multiply by square root of x plus by 2. Now if I multiply this thing, what I said just now is if you multiply this thing, you can get away from the square root here. So this will give me the answer of, so if you multiply the bottom here, you get, so here is x squared minus by 16. This is the square root of x plus by 2. So if you multiply here, we get x squared minus by 4. X squared minus by 4. Okay, this is the limit of x approach to 2. X approach to 2. Now x so how to get this one? I will want to show how to get this one. So this one is this from square root of x minus by 2 multiplied by square root of x plus by 2. This is equal to square root of x multiplied by square root of x is x. Okay. So square root of x multiplied by 2 is plus 2 square root of x. Negative 2 multiplied by square root of x is negative 2 square root of x. Negative 2 multiplied by positive 2 is negative 4. Okay, this is the same value. Plus and minus is, you can solve this one. Then you will get sorry, this is x minus by 4. This one is 4. So you will get x minus by 4. Okay, x minus by 4. Understand? Okay, this is the x minus by 4. Now, so here is x minus by 4, and now we know that if I have x squared minus by 9, this is equal to, this is 1 and more than 1, is x minus by 3, x plus by 3. Now if I have x squared minus by 4, this is equal to x minus by 2, x plus by 2. Now if I have x squared minus by, let's say minus by 4, 9, 25. This is equal to x minus by 5, x plus by 5. Now if I have x squared minus by 16. So this is equal to x minus by 4, x plus by 4. Okay, so you can write like this. This is equal to limit of x approach to 2. X squared minus by 16 is x minus by 4. X plus by 4. X plus by 4. Multiplied by square root of x plus by 2 divided by x minus by 4. Now, x minus by 4 and x minus by 4, this can be cancelled off here. So, the final answer here is you will get x limit of, go here, limit of x approach to 2, x plus 4, square root of x plus 2. Okay. Now you solve this one. So if I solve this one, I have limit x approach to 2. So I solve this one, I will get x multiplied by square root of x. So x multiplied by square root of x, x multiplied by square root of x. Square root of x x square root of x, x multiplied by 2 is plus by 2x, then plus by 4 multiplied by, this one is x multiplied by square root of x, then here is x multiplied by 2 is 2x plus by 4 multiplied by square root of x, then 4 multiplied by 2 is equal to 4 multiplied by 2 is equal to 8 plus by 8. Then if you substitute the value here, you substitute the value of 2 here, you will get, this will give me a limit of, you get, if you substitute the value here, you get 2 square root of 2 plus by 2 multiplied by 2 plus by 4 multiplied by square root of 2, plus by 8. So 2 plus by 4 square root of 2 is 6 square root of 2 plus by 4 plus by 8. So this will give me the answer of 6 square root of 2 plus by 12. This is the final answer for the example is now. Okay, the notes there, those for number D, you have to make some changes. This is the final answer for number D. There's something wrong there. Number D in my notes, you have to make some changes here. This is the final answer for D. Okay, the next part is limits as x approach to infinity. Limit as x approach infinity. Here is 3.3. Now, look at example 3.1. Example 3.1. 3.11. Now, the rules of limit x approach to infinity, we have you have to see this rule. We have, if I have a radical function. So I have a rational function. If I have a rational function, Now let's say I have example here. I have rational function. Let's say I have limit of, this is a case of x approach to infinity. So x approach to infinity. This is the only case for x approach. Remember, this is the only case for x approach to infinity. Now, if I have here my ratio, my exponential, let's say I have x raised 2 over x raised 3, this will give me the answer of 0. In other words, if the power in numerator is greater than the power in denominator, so these are 2 and this is 3, so the answer will be 0. This is the first rule. Rule number 1. Rule number 2, limit of, this is only case for x approach to infinity. Now, if I have the same value here, x, let's say x raised 3, 2x raised 3 over 5x raised 3, the same power here, the same power there. So this will give me the answer of, you can refer to the coefficient here. Here is 2 and 5. The answer here is equal to 2 over 5. Okay. Now, if I have the third rule here, limit of x approach to infinity. Now, if I have x raised 3 over x raised 2, this is equal to plus and minus infinity, or the limit does not exist. The value does not, this is the limit does not, or the limit does not exist. As you see, does not exist. So, or you can put like D and E. The limit does not exist. Okay. So, if the power here, the numerator is greater than the denominator, so the answer is plus and minus negativity, or the limit does not exist. It is how you solve x approach to infinity. So look at a few examples here. Now, example number 1, A. So I have here limits of x approach to infinity, and then x raised 2 plus by 3. Okay. For this case, we cannot apply the rules that I give just now, because we do not have this is a normal function. It's not a rational function. So we just substitute infinity into this function. You can imagine infinity is a very large value. Okay, so a very large value, you substitute here into x squared. Infinity you substitute into x here. Very large value square become a very large value, plus by 3 become a very large value. So that's why the answer here is equal to very large value, or infinity. Okay, B. So now B, limit of x approach to infinity. So 2 over x minus by 2. So I can apply the rules that we discussed just now. If I have the above one is lower than the bottom one, numerator the numerator power is lower than the denominator power, so the answer will be 0, because this is referred to, this can be written as 2x raised 0 over x raised 1 minus by 2. This is the same thing. X raised 0 is equal to 1. X raised 1 is x minus by 2. So this is greater than, this lower than this one is equal to 0. That's why the answer here is equal to, the answer there is equal to 0. This can be written as x raised 1 minus by 2. So the top here is 0, the bottom one is 1. So, or you can solve like this. Okay, you can solve like this. To solve the rational function here, we have to solve x here. The highest power here is x raised 1, x to the power of 1. So you divide everything by x to the power of 1. So for this case, these are the first way to solve this one. So another way for solving this one, we have, look at here, we have here is x, the highest power here, x is raised 1, or x to the power of 1. So divide everything by x to the power of 1. So I have here limit of x approach to infinity. So 2 divided by x over x divided by x minus by 2 divided by x. So here is 2 divided by x over x divided by x is equal to 1 minus by 2 divided by x. So a very large number divide a small number divided by a very large number, x is infinity. 2 divided by infinity is equal to 0. 1 minus by 2 divided by a very large number is equal to 0. 0 divided by 1 is equal to 0. This is how you solve the problem here. Okay, C. C, I have limit of x approach to 2, x minus by 2 divided by x raised 2 minus by 4. If you apply the rules that we discussed just now, we can see that the numerator here is raised 1, x raised 1, and the denominator is x raised 2. So you minus by 2, this minus by 4. These are lower than, the denominator is larger than the numerator, the answer will be 0. Okay, to solve this one, another way of solving this one, we can solve this way, limit of x approach to 2. So divide everything by the largest power. Okay. So we divide everything by the largest power, meaning to say we divide everything by x raised 2. So x, the largest power is x raised 2, so x over x raised 2 minus by 2 over x raised 2 over x raised 2 over x raised 2 minus by 4 over x raised 2. So this is equal to 1 over x minus by 2 over x raised 2 over 1 minus by 4 over x raised 2. So the thing here, if you substitute x approach to 2 here, sorry, approach to infinity, approach to infinity, this is approach to infinity. Now, if you divide 1 divided by a very large number, you will get 0 here. 2 divided by a very large number, you will get 0. 1 is 1. 4 divided by a very large number, you will get 0. So 0 divided by 1 is equal to 0. The same answer like top one. This is how we solve C. And D, I have, so D is x raised 3 over x limit of, this is a case of x approach to infinity, x raised 3 minus by 2 over x raised x raised 3 over 2 over x raised 2 minus by 4. So if the denominator is greater than the numerator, the answer will be the limit does not exist, or you can put here the answer is positive or negative infinity, or the limit does not exist. The limit does not exist. So to prove this one, we can divide by the largest power here. The largest power here is x raised 3. So you divide everything by x raised 3. X raised 3 divided by x raised 3 minus by 2 divided by x raised 3 divided by x squared divided by x raised 3 minus by 4 divided by x raised 3. Limit of x approach to infinity. Okay, x raised 3 divided by x raised 3 is equal to 1 here. So you get limit of x approach to infinity. Here is 1 minus by 2 over x raised 3 divided by x raised 2 over x raised 3 is 1 over x minus by 4 over. So if you substitute here, you substitute the value here. So 2 over x raised 3, this is equal to 0. Small number divided by very large number is equal to 0. This also equal to 0. And this also equal to 0. So 1 divided by 0 is infinity. Okay. So 1, this is, we give you the answer of 1 divided by 0 is equal to infinity, or does not exist. Okay. So then we go to example E. Limit of x approach to infinity, x raised 3 minus by 2 divided by x raised 3 minus by 4. By the rules there, the rule that I give you just now, if we have a same value, same power here, we have a same power, we have x raised 3, the numerator x raised 3, then and the denominator is x raised 3, the answer will be the first coefficient. The coefficient is here is equal to 1, this is equal to 1. So 1 divided by 1 is equal to 1. Okay, because we have the same power. Or you can put this way, limit of x approach to infinity, you divide by the highest power here, x raised 3 divided by x raised 3 minus by 2 divided by x raised 3 divided by x raised 3 divided by x raised 3 minus by 4 divided by x raised 3. So here we give me the answer of limit of x approach to infinity, 1 minus by 2 over x raised 3 divided by 1 minus by 4x raised 3. This is equal to 0, this one, very small value divided by very large value is equal to 0. Small value divided by very large value is equal to 0. So limit of x approach to infinity, 1 divided by 1 is equal to 1. Okay, the same answer. Yes. On to find limit of x approach to infinity, square root of 2 plus by square root of x plus by two. Okay. So to solve this one, to solve the radical function, just now we multiply by certain value. So for this case, you can multiply by, just now if you have Square root of x minus by 2, you just multiply by x plus by 2. Now, if you have x plus by 2, you just multiply by square root of x minus by 2. So don't forget to put down here square root of x minus by 2. So this way. Again, so this can be written as square root of x plus by 2. This is equal to limit of x approach to infinity, square root of x plus by 2, then you multiply by, you want to get it from, you want to cancel off this square root, the radical equation, the radical function here. So square root of x minus by 2 divided by square root of x minus by 2. So this is how you solve from here. So this will give you the answer of square root of x multiplied by square root of x is equal to x. And this will give you the answer of negative x minus by 4, square root of x minus by 2. Now, since the function here, this can be written as x raised 1 minus by 4 over x raised half minus by 2. Because of this thing, this is higher than this 1 and this is a half. This is higher than this one. By definition, if you refer to the rules of limits x approach to infinity, the numerator is higher than the denominator. This is equal to positive and negative infinity, or does not exist. Okay, this does not exist. Or you can solve like this. Okay, you can solve this way. The highest equation here is x raised 1. So the highest power here is x. The highest power here is 1. So everything we divide by x raised 1. So x raised 1 divided by x raised 1 minus by 4 divided by x raised 1. And put here limit. Eh? So limit. This is a limit of x approach to infinity. Here is limit of x approach to infinity. Here is x raised 1 minus by 4 is x raised half minus by 2. This equal to, because this is higher than this one, this equal to plus and minus infinity, or does not exist. Okay. This the first way we solve the limit here. Or you can solve this way. You can solve like this, or you can solve limits of x approach to infinity, x raised 1 over minus by 4 is x square root of x raised half minus by 2. So this will give me the answer of limit of, so the highest power here is 1. So everything we divide by x raised 1. So x raised 1, so put here limits, x approach to infinity, x raised 1 divided by x raised 1 minus by 4 divided by x raised 1 over x raised half divided by x raised 1 minus by 2 divided by x raised 1. Okay, so this will give me the answer of x raised 1 divided by x raised 1 is equal to 1 minus by 4 over x raised 1 over 4 over x. Half power of x power half divided by x raised 1 is equal to So you have here is you can put here is 1 over x raised 1. One this can be you can put this half is 1 over x raised half minus by 2 over x. So here is equal to the limit of x approach to infinity 1 minus by this small value divided by very large value is equal to 0 divided by this equal to, so this is equal to 1 minus by a small value by very large value infinity is equal to 0. Then small number divided by a very large number is equal to 0. And this is a small number divided by a very large number is equal to 0. So 1 divided by 0 is equal to infinity. So this is how we solve the problem here. Okay. The last one is G. G, how to solve G? So G, we have a limit of as approach to infinity square root of x raised 2 plus by 2x minus by x. So to solve this one, to solve the radical function here, the rows here we can multiply the same function, but we just change the symbol here. So this is equal to limit of x approach to infinity square root of x raised 2 plus by 2x minus by x. You multiply by square root of x raised 2 plus by 2x plus by x. Okay, plus by x. Minus is plus. So then don't forget to divide by the same value here. So divide by square root of x raised 2 plus by 2x, okay, plus by x. Okay. So the top here, this will become this thing multiplied by this thing, you get x raised 2 plus by 2x. Then this time multiplied by this thing is minus by x squared. Divide by square root of x plus by 2x plus by x. Okay, x squared minus by 2x. So x squared minus by, this can be written as, this is limit of x goes to infinity. This can be written as limit of x goes to infinity. X squared minus by x squared is 0. So the answer here is 2x divided by square root of x plus by 2x plus by x. Now, the highest power here is equal to 1, isn't it? Here is 1, x raised 1. Okay. Here is also x raised 1. This is actually x raised half, because we have square root here. This is actually x raised half. This is also actually x raised half. So the highest power here is x raised 1. X raised 1. So to solve this one, you can see that here is x raised 1, and here is x raised half. This x raised 1 as x raised 1. Okay. Okay, here is x raised 1, and here's also x raised 1. We have the same value there. The answer should be either 1 or the most probably the answer will be most probably the answer will be 1 or 2 or 1. So we can check the answer here. So by right, so if we have the same power here is x raised 1, here is x. By right, the answer here is equal to, if you refer to our rows there just now, here is raised 1, the same power. Okay, so by right, the answer here is equal to, 2. The answer here is equal to 2. Okay, we try to show the answer is equal to 2. The answer equal to 2. Okay, try to show this one, the answer equal to 2. Or maybe the answer is equal to 1. We try to prove that. Okay, now, so 2 or 1. So now, if you solve this one, the highest power here is equal to 1. Here is half, and here is half. So we have to divide by x raised 1. So everything that you divide by x raised 1, so this will give me the answer of limit of x opposed to infinity. Divide everything by x raised 1, 2x divided by x over, here is plus x divided by x, and here is square root of. So because of here is square root, if I divide by x, meaning to say I divide by x raised half, so I have to divide by x raised 2. Because of square root of x raised 2 is equal to x raised 1. So that's why I have to divide by x raised 2, because of there is a square root here. So I divide by x raised 2. Here is x plus by 2x divided by x raised 2. So this will give you the answer of 2x divided by x is equal to 2 over, here is square root of 1 over x raised 2, x over x raised 2 is 1 over x, plus by 2, here is, here is x raised 2, x raised 2 divided by x raised 2, okay, x raised 2 divided by x raised 2. Okay, I repeat again, I repeat again. Now, our function here is square root of, if you solve this one, you get x raised 2 plus by 2x, negative and positive is plus by x squared over, negative and positive negative, over square root of x raised 2 plus by 2x plus by x. Okay. This is equal to x squared minus by x squared is 0. The answer is 2x over square root of x squared plus by 2x plus by x. Okay. The highest power here is x. X raised 1, here is x raised 1. And this also x, this, even though this is x raised 2, but actually this is x raised 1 because of you have the square root here. So this actually is x raised 2, square root is x raised 1. So the highest power is x raised 1. So that's why we divide everything by x raised 1. So this is equal to, here is limit x approach to infinity. So we divide everything here by x raised 1. So here we have limit of x approach to infinity. You divide everything by x raised 1, 2 over x over square root of x raised 2 plus by 2x plus by x divided by x. Since you have a square root here, instead of divide by x, we have to divide by x squared. Because of x squared, You square root it become x, so we divide by x squared here. Here divide by x squared. So here is limit of x approach to infinity. 2x divided by x is 2 over square root of x squared divided by x squared is equal to 1 plus by 2x divided by x squared is 2 over x, okay, plus by 1. So this will give you the answer of. So if you are at substitute infinity to this function, I will get limit of x approach to infinity, okay, then 2 over square root of 1 plus by 0 plus by 1. So this will give me the answer of limit of x approach to infinity. 2 over square root of 1 is equal to 1 plus by 1. So the answer will be equal to 2 divided by 2 is equal to 1. This is the final answer. Okay, the last lesson here is on continuity. 3.4 on continuity. Now, by definition, if C is an interior point, of domain F, then limit x approach to infinity of fx exists and equals fc. Okay, by definition, it requires three things here. One is fc exists. Then number 2, limit of x approach to c fx exists. And then 3, limit of x approach to c fx is equal to fc. These are by definition. Okay, now look at example 3.12. Okay. Now example 3.12, we want to find whether example 3.12. We want to test whether fx equal to x raised to plus by x minus by 2 over x minus by 1 continuous at c is equal to 1. So we just plug in c is equal to 1 into this function. So fc, so 1 raised to plus by 1 minus by 2 over 1 minus by 1 is equal to, so 1 plus 1 square, 1 raised to plus by 1 minus by 2 is equal to 2 minus by 2 over 1 minus by 1 is equal to 0 minus by 0. Anything divided by 0 is undefined, does not exist. this does not exist. So this does not. This we can refer here is as a does not exist. Okay? So if does not exist, if FC does not exist, you can refer to the definition here. If FC does not exist, so this does not exist. For continuous, FC must exist. If this does not exist, we can say that this does not continuous, does not continuous at C is equal to 1. Okay, does not continuous at C equal to 1. This is how we solve. So once you get the answer here, you have to compare the definition here. If this function or this result does not meet the definition here, so this function does not continuous at C is equal to 1. Okay, then we go to example 3.12. Say 3.13. 3.13. So I have example 3.13. Now, example 3.13, I have this function. 3.13, last example 3.13. 3.13. I want to find, given that fx is equal to x raised to plus x minus by 2 over x minus by 1. Here is 2. Now, this is if x is not equal to 1, and here for x equal to 1. So, first of all, I want to find, so the solution here is, if I have, so f1 equal to, I have f1, so if I put c is equal to 1, so fx equal to 1, so this is equal to 2. You need to say this exists. I have a value here, exists. Now, if I want to find the limits of x in this is x is equal to 1. This can be a positive direction, or negative direction. This can be, it's not just not equal to 1, can be greater than 1 and can be less than 1. Okay, so less than 1 is in a negative direction, greater than 1 is in the positive direction. So if I want to find a limit here, limit x approach to, let's say I want to find limit because of here 1. So here we x is equal to 1. So I want to find x approach to 1. So limit of x approach to 1, fx. Okay. So I need to find two directions. One is a negative, then the other one is positive. So I need to find limit of x approach to positive direction. Okay. So the function there is x raised. Why don't you take 2 here? Because of here is x is equal to 1. I want to find x approach to 1. It's not exactly 1. X is equal to 1 is 2. This exists. I want to find x approach to 1. So this x approach to 1. X does not equal to 1, but x just approach to 1. So in the positive direction, we have this x approach to 1, meaning to say you can either have negative or positive direction. X approach to 1, positive direction. X raised 2 plus by x minus by 2 over x minus by 1. Okay, this can be written as, you can simplify this thing. This can be written as limit of x approach to. So this can be written as x minus by x plus 2 x minus by 1 divided by x minus by 1. Okay, so so if I solve this one, I can cancel off this part. Okay? You can do this way. You can this can be cancelled off. I have here limit of x approach to 1 in positive direction, x plus by 2. So if I substitute 1 here, I will get 3. So this thing also apply for the negative direction. So for the negative direction, okay, so I have this positive direction, I have a negative direction. So I have, for the negative direction, I use the same function here because of this is meant for positive and negative direction. So limit of x approach to 1 in negative direction. So I use the same function because of this only not equal to 1, but it refer to positive and negative direction. So negative direction is the same, also the same function, x squared plus by x minus by 2, x minus by 1. This can be written as limit of x approach to 1 negative direction, x plus 2, x minus 1, x minus 1, this can be cancelled off. So if I substitute the value of 1 here, so I'll get a is equal to 1 plus by 2 is equal to 3. So meaning to say, because of limit of x approach to 1 in positive direction, fx equal to limit of x approach to 1 in negative direction. Okay, so therefore the limit is this equal to 3, and this also equal to 3. Okay? Therefore, limit of x approach to 1 fx equal to 3, meaning that the limit of x exists. This exists. You can see that this exists. So we have proved that the first one exists. f1 is equal to 2. Then the limit of first, second, the limit of x approach to 1 is equal to 3 exists. Fx is 3 exists. Then but the other problem is the third one. We cannot prove that. If I have here the third one, we have three conditions. First condition is FC exists. So the first condition FC exists where F1 equal to F1 is equal to 2. Okay, F1 equal to 2. F1 equal to 2 exists. Okay, then limit of x approach to 1, fx equal to 3 exists. Okay, 2. Number 3, the definition said that we have to prove that limit of x approach to c fx equal to fc. So for this case, limit of x approach to c or limit of x approach to 1, fx is equal to 3, isn't it? So this is equal to 3, and this is not equal to 3. F1 is equal to 2. So limit of x approach to 1, for our case, limit of x approach to 1, fx does not equal to f3. So f1 does not equal to f1. So this does not continuous. This does not. So in other words, therefore, you can put a function and therefore fx does not continuous at C. So to show that a continuous case, we have to prove the three conditions. Here is a condition 1, condition 2, condition 3. So we have proved condition 1 and condition 2, but we cannot show that the condition 3. So because our limit x approach to 1 is not equal to f1, therefore fx does not continuous at C. This is the final answer for example 3.13. I think that's all for today. Okay. So I will give you some example on some exercise on this one. Okay, you can refer to my guru. I will upload the exercise, okay, for limits and continuity. And for your information, this lecture is for week 6 lecture, week 6. Okay. So assignments, the assignment and the exercise I will upload in my guru. And for the meanwhile, please refer to example that I give you from the beginning, lecture 5 and lecture 6. Okay? Then try to solve the example that I give to you, the problem that I give to you. Try to understand that. Then I will upload some exercise in my guru. You can refer to my guru. Assalamualaikum warahmatullahi wabarakatuh.